Alright, so today I'm going to show you how the winds change in the north and the south, in the northern hemisphere and the southern hemisphere. It's all because of the Coriolis effect and the apparent rotation of the planet. So let's start first with the northern hemisphere. See, in the northern hemisphere, the apparent rotation of the planet looking up from the North Pole is going to be counterclockwise. Okay, so just like with that carousel example, I'm going to show you what happens. If you have an object that's being thrown in what you think is straight, and then you rotate that plane in a certain direction, it's going to bend its trajectory. So I'm going to push this marker forward, and at the same time I'm going to turn this piece of paper counterclockwise. Okay, see what happens. See, the apparent motion, just like when you throw the ball to your friend on the carousel, it's going to veer to the right as long as it's going counterclockwise. So that's from the equator to the North Pole. Okay, see what happens from the northwest to the northeast. Same thing, I'm going to push this marker forward and I'm going to move this counterclockwise. Same thing, veer to the right. Let's do it from the North Pole down to the equator, still going counterclockwise. Push the marker forward, veer to the right. Let's do it from the northeast to the northwest. I'm going to push this marker forward, turn the paper counterclockwise, veer to the right. So let's see what happens in the southern hemisphere. What's going to change now? Okay, the apparent motion is going to be clockwise. Okay, so let's go from the South Pole up to the equator, except this time I'm going to rotate clockwise. So I'm going to push the object forward, rotate the earth clockwise. The apparent motion was to the left. Let's go from the southwest to the southeast. Rotate it clockwise. Push it forward, rotate it clockwise. The apparent motion is to the left. Let's go from the equator down to the South Pole. Push the object forward, rotate it clockwise. It's gonna veer to the left again. Let's go from the southeast to the southwest. Push it forward, rotate it clockwise. The apparent motion is gonna go to the left. See? So as you can see, if you're in the northern hemisphere, the wind's always gonna veer to the right. No matter what direction that you're coming from, they're always going to veer to the right. If you're in the southern hemisphere, no matter what direction you're coming from, they're always going to veer to the left. And this is because of the way that the Earth rotates. It's the apparent rotation of the planet. So let's look at this. I'm going to wind up this box. What I want you to do, we're going to look at this from two different vantage points. This spinning blue piece of paper, okay? So first, let's look at it from the top. So imagine that you're on the North Pole right now. This piece of paper, this little dancing thing on the top is rotating clockwise, but this piece of paper is rotating counterclockwise. Counterclockwise. What's going to happen if I go down to the South Pole? That piece of paper is going to be rotating in an apparently completely different direction. Now it's rotating clockwise. It's all about the vantage point. This is why the winds veer in certain directions depending on what hemisphere you're in, because of the constant rotation of the planet. Coriolis effect, guys.